Okay, so welcome back. So just like I promised that I'll create another video, okay, on Euler's method. Okay, so in this video I'll solve the same problem, okay, the same problem given, but now using Euler's method, and we are trying to find the value of y at t is equal to 0.8 given here. Okay, so let's see. So the same problem, right? So this is Euler's method here. So same problem, dy dt, or we can just say f of t comma y equal to t squared y plus 1. The same interval, okay, the same interval 0 to 1. Okay, those are values of t, and also the same initial condition y of 0 equal to 1. But this time around we are trying to evaluate at y of 0.8. So you need to find what value of y you get when t is equal to 0.8. Okay, so let me just write Euler's formula. And of course, I'll use my own notation here. So Euler's method for IVP. So I'll use my own notation. So y is given by y of I is equal to y of I minus 1 plus h f of t comma I t subscript I comma y of I. So this is Euler's method. Okay. So where h is simply, of course, the step size. Since we are given the interval and we are told that we want to have 5 sub-intervals in that interval. So we can find the value of h. What's the value of step size? Okay, so we're given the interval and we say that h is simply equal to b minus a divided by the number of step size, which is n. So we can get our h from this, which is just 1 minus 0 over 5. So our h is equal to 0.2. Okay, so we know our h. So this one here is a value of y at ti. Okay, this is the value of y at ti. Sorry, so this one actually I need to make a correction on this. So it should be ti minus 1 as well, comma yi minus 1. So this is the value of y you get at ti. So from what you're given here, let me just get some intervals for you. So we are given t naught is equal to 0, because that's the starting value. And then also y naught is also given at that point, is equal to 1. Now what of t1? Okay, what will be t1? So when I is equal to 1, what will be t1? So t1 will be equal to, remember that we are moving, it's more like, it's like we're dividing a function, right, into some sub-intervals. So these are the intervals. This is t is equal to 0, t equal to 1, t equal to 2, t equal to 3, until we reach at 0.8, right? So this is 0.2, 0.4, so up to 0.8. So you notice that we have 5 sub-intervals. Okay. Well, sorry, we have those 5 intervals there. So now the first value, okay, the first value, so we need just 4 sub-intervals, therefore to reach at 0.8, right? You need to move 4 times because we're moving each step size is equal to 0.2. So meaning that at t1, we're going to have t1 will be equal to 0.2. The next one, t2, will be equal to 0.4. The next one, t3, will be equal to 0.6. And then our t4, which is the last one, we've reached at 0.8, right? So this is 0.8. So we have to evaluate at all these points here. So what we can do here, we can't evaluate, let's say, at y of 0.5. The reason being is that our step size moves in this order, right? So 0.2, 0.4, 0.6, 0.8 is 1.0, 1.2, just like that. So we can, there's no way we can evaluate this at t is equal to 0.5. Okay. So for instance, again, if for instance our h was equal to 0.1, then there's no way we can evaluate this, let's say, at 0.15, something like this. They can't do this, okay? Because our step size just is 0.1. So believing 0.1, 0.2, 0.3, 0.4, if the initial condition is at 0, right? For example, here, t naught is equal to 0. So if the initial condition is 0, the next one will be at 0.1, 0.2, 0.3, just like that, if our h is equal to 0.1. Okay, so here our h is equal to 0.2, so we can't evaluate this as 0.5. Okay, we can evaluate as 0.4, we can evaluate as 0.6, we can evaluate as 0.2, but not at 0.6, 0.5, 0.3, 0.1. We can't do that. Okay. All right. So we have these values of t. Okay. So we're going to use the formula. Okay. So we're going to use the formula given, which is y of I equal to y of I minus 1. Y of I minus 1 is simply the previous value of I of y, and then plus h times f of t subscript I minus 1, comma y subscript I minus 1. Okay. So we start the first iteration, right? So to be at t1, okay, because at t naught everything is already simplified for us. At t naught we have t naught is equal to 0, y naught is equal to 1. So we don't have to find that. So we start at t1. At t1, which is what? At t is equal to 0.2. Okay. So start with the first iteration. This will be y1. So y1 will be equal to, when I is equal to 1, this is y0. Okay, plus h. Okay, f of t0, comma y0. Okay. So we have to use the previous values for us to find the next value, isn't it? So the previous values of t and y for us to find the next value, which is y1. Okay, so let's substitute. So y1 will be equal to our y naught. Remember that our y naught just equal to 1. Our h, which is step size 0.2. This will be f of O. At t naught is simply equal to, we have what? 0. T1 we have y naught we have 1 as well. So we replace this in a function. Okay, so 1 plus 0.2. Here t is equal to 0, so 0 squared times y is equal to 1, and then plus 1. Remember our function given there, which is this function I'm using here. Okay, this function here. So I'm just substituting here for the value of t as well as for the value of y. So upon doing that, we have what? 1.2. So I get 1.2 at this is that t is equal to 0.2. So the value of y is equal to 1.2. So this is simply t1, y1. Okay, so f of t y1, y1. So we have that value, which is what? 1.2. So therefore we can write that in y at 0.2, which is equal to f of t1. Okay, this is approximately equal to the y1 we found, which is equal to 1.2. Okay, so that's the first approximation. Now we move to the next step. Okay, so we move now to t2 until we reach t4, which is 0.8. So t2 now, this will correspond to y2 as well. So y2 will be equal to, so now we're going to use the previous value. So this will be y1 plus h times f of t1, y1. Okay, so we substitute the values. So y2 will be equal to y1 just from calculating the value of y1, which is 1.2. So 1.2 plus h, our h is 0.2, f of t1. Okay, so our t1, remember that our t1 now is this value, the previous value of t, right, which is 0.2. Okay, so 0.2, comma, our y1, which is 1.2. So we're going to substitute these values. Okay, so 1.2 plus 0.2. Okay, so in our function, our t is equal to 0.2, so 0.2 squared, our y is 1.2, and then plus 1. And if you punch this on your calculator, you should be able to get 1.4096. Okay, 1.4096. So therefore, we can conclude that y at 0.4, okay, at t is equal to 0.4, which is the same as f of t2, is approximately equal to f of y of 2, and this is equal to 1.4096. Okay, can present it either way. All right, so we're done with T2, we're done at T1 as well. So let's move to the next one. So we're going to evaluate this at T3 now. So we're going to find Y3. So Y3 will be equal to Y2, at the previous value, plus H, F of T2, comma Y2. Okay, so we evaluate that as well. So Y3 is equal to Y2. Y2 is simply 1.4096. And H is 0.2. F of our T2 is the previous value of T2 is 0.4, comma 1.4096. Okay, so we evaluate this 1.4096 plus 0.2. We substitute our function. Our T is equal to 0.4 squared times our Y, which is 1.4096 plus 1. And if you do that, you must be able to get the value of Y3 equal to 1.65 47072. Okay, so that's the value of Y3. So we can therefore say that Y at 0.6, which is the same as what? Y at T3 is approximately equal to Y3, and this is equal to 1.65 47072. Okay, one more step, right? Remember at 0.6, so we need to reach 0.8. Okay, so this will be our T4. So our T4, Y of 4, so Y4 will be equal to Y3 plus H of F at T3, Y3. Okay, so our Y3 is just the previous value we've calculated, which is 1.6547072. Our H is 0.2. F of T3. Our T3 is simply 0.6, right? I think our T3 is 0.6, as you can see here. So I have 0.6, comma, Y3, which is 1.65 47072. Okay. As usual, we substitute this in our function. So our T is equal to 0.6 squared times 1.6547072 plus 1. Okay. So if we simplify that, our Y4 will be equal to 1.973846,118. So therefore, we can conclude now that Y at 0.8, which is the same as Y at T4, is approximately equal to 1.97, or okay, it's approximately equal to Y of 4, which is equal to 1.973846,118. So this is our Y of 0.8. Okay, so we come to the end of our problem here. So this is our solution, and if you have any queries, please let me know. Okay, you can just drop your comment in this comment section there. I'll be able to read your comments. Thank you so much, and God bless you all.